So if you're joining us, we're going to get started in about 2 minutes. Welcome, make yourselves at home. We're excited about the next hour of exciting talk. So we'll get started here in just a bit.
Adjust my seat so you can see the Washington Nationals sign behind me.
I'm sure everybody joining from Washington, D.C. will be really excited.
It should be.
For that walk down memory lane.
Oh.
I see Amanda, but I don't see Blake.
We're waiting on Blake.
We're waiting on him.
Okay, is he going to be on the top screen?
It moves around. Look. Who's that guy?
Check that out.
I know, right?
Yeah.
All right, so I'm gonna go ahead and get started, I think, and hopefully Blake will be on by the time I introduce him. And I'll talk very slowly. So
I can't believe that, but go ahead.
Hey, wait. Hello everyone, and welcome to Talented Innovators, Fantastic Aircraft, Creating the Future of Aerospace. I am Amy Spowert, President and CEO of the National Aviation Hall of Fame. This is the 5th in a series of webinars being brought to you by a collaboration between the National Aviation Hall of Fame and the National Aeronautic Association. Our missions combine by recognizing the most legendary people and the most remarkable achievements in aviation and aerospace. To learn more about our organizations, please visit our websites. Members of the Hall of Fame and the NAA received advance notice of today's webinar and were able to sign up early for this limited opportunity. This will be the same for future events, so please consider becoming a member. As we go through this webinar, please feel free to send your questions and we will do our best to work them into the conversation. And today, we will be giving away a personally signed copy of Dick Rutan's book. Be sure to stay tuned to the end to hear if you are the lucky winner. Throughout the history of aviation, progress has been achieved by those who dare to imagine and dream of creating technologies once considered impossible or implausible. And so it is today. To continue to advance, to continue to serve the needs of society, aviation must continue and is continuing to innovate, to create fantastic aircraft that continue to make the world smaller and open opportunities for travel and growth around the world. To help us examine all this, we have an amazing panel for you today. Dick Rutan was enshrined in the National Aviation Hall of Fame in 2002. He is a true heir to the traditions of innovation and invention begun by the Wright brothers, willing to dare and dream and risk it all. Whether as a combat pilot with 325 missions in Vietnam, a test pilot, or as the pilot of the first non-stop, non-refueling around-the-world flight in the Voyager aircraft in December 1986, Dick has always reached beyond the bounds of the simplest possible way to achieve the incredible. Dick is a recipient of the National Aeronautic Association Collier Trophy for the Voyager flight. Amanda Simpson is the Vice President for Research and Technology at Airbus, where, among other initiatives, she's working on a project to transition to hydrogen propulsion with a goal of entering such aircraft into commercial service in the next decade. This requires a reimagining of the entire aircraft as well as development of new infrastructure. Prior to Airbus, Amanda, kind of an overachiever, served as Deputy Assistant Secretary of Defense for Operational Energy, as well as Executive Director of the U.S. Army Office of Energy Initiatives. She previously worked for Hughes Aircraft and for Raytheon, including as a test pilot. Blake Scholl is the founder and CEO of Boom Supersonic. Under his leadership, Boom is building the world's fastest airliner, Overture. Boom recently unveiled its demonstrator aircraft XB-1 as history's first independently developed supersonic jet. They aim to pave the way for a mainstream supersonic flight by demonstrating the technologies for safe, efficient, and sustainable high-speed flight. Blake was inspired by seeing a Concorde in a museum and became determined that supersonic travel could be a part of aviation's future. Oh my gosh. Co-moderating, see, Greg has written these introductions, everyone, and Greg is not shy about words. So co-moderating with me is Greg Principato, President and CEO of the National Aeronautic Association. Let's get started. When Greg and I talk about what our next topic will be, we start with the mission of the NAA to award aviation's best achievements and the Hall of Fame's mission to honor aviation's best people. Today, we're going to explore what happens when our dreamer takes the beauty of the Concorde and applies today's technologies, and an industry leader who takes aviation to the next level by applying today's sustainability possibilities. Undoubtedly, Boom and Airbus can only be inspired by the people who came before. When Hall of Fame enshrinee Dick Rutan was a little boy, he knew that he wanted to make a name for himself in aviation. In 1986, Dick flew the Voyager, the first aircraft to go around the world without refueling in 9 days, 3 minutes, and 44 seconds, earning him the 1986 Collier Award. Dick, if you make something from nothing, how do you know it'll work? How did you do it, Dick? How do you test something if you don't know it's going to work?
Well, that's what flight test is all about. Somebody has an idea, like my brother. He says, "Hey, Dick, not even thinking about this." Remember, this is back in the days before they had internet, and back in the days before they had GPS. I mean, a lot of us can't even realize that there was a time in this earth that we had no GPS. Anyway, he says, "Hey, I think it's possible to fly nonstop, non-refueled around the world." And I looked at him and I thought, no way. But right away, I realized that was going to be a major milestone achievement. And I looked in his eyes and I says, "Bert, do you really think that we can build an airplane to do that?" Now, here we are in a high little desert town, Mojave. If you've ever been to Mojave, it's a town where your wife, when you drive in, your wife will look around and she won't let you stop. But anyway, it has an airport, and it's known for being innovative and creative. And if you got a dream, well, come and you can try it here in Mojave. And so when I finally realized that he thought that he was serious, you really can do that, then for a minute, it kind of settled into my psyche what this would mean. This would be a major aviation milestone, an unrefueled, nonstop flight around the world. Holy bananas, are you really serious about that? And from that feeling that morning, when he said that, I thought, wow, that is exactly, if Bird, it says, if you think that you can design this, we'll build it. And I don't know two people more qualified to fly it around the world. And so then we were off in this 5.5-year odyssey, having no idea how difficult it was going to be. And the rest is in my new book, The Next 5 Minutes.
You mean this one?
That's right. The book starts at, try to describe the feeling and the situation as we sat on the end of the runway on that cold December morning in 1986 and looked down that runway after having a big argument with my brother about the amount of fuel on board. I wanted more, he wanted less. I didn't want to have to do it over again. And that feeling I had that morning as I looked around and released a little brake and started rolling down the world's longest runway, wondering if I would be alive in the next 5 minutes.
Dang. I don't know if I should go to Amanda or Blake from that. So what I'm going to say is, Amanda, tell us what it's like for you having been a test pilot. And then I want to hear from Blake. I want to know if he's ready for this. I want to know if he's ready for his 5 minutes. So Amanda, you go ahead first, and then we'll hear from Blake.
Well, thank you, and you know, an honor to be associated on a panel with Dick and Blake. And while I was a test pilot for 20 years, I wasn't doing things like Dick did. I, for the most part, was taking existing aircraft certified for one thing and modifying them to do tests of systems, whether that be new avionics systems, missiles or radars. So we were strapping things to the belly or sticking them out the nose or, out a wing, or even we did some work up out of Mojave in California City. Dick's very familiar with those, since he holds the world's record for the fastest flight between Mojave and California City in his rocket-powered aircraft, towing things behind our aircraft. But like Dick, you take a step-by-step approach. You don't go for the full whiz-bang envelope right off. You slowly expand and push certain corners until you know that it's safe to move a little bit further. And you do it in a very defined and methodical way. I've always had a lot of friends go, you've got to be absolutely insane to be flying these test missions as a test pilot. And I said, you know what, it's one of the safest things I've done, because we think things out. We have contingency. So if this goes wrong, what do we do? If this were to happen, how do we deal with it? And I've got some things that I can't put into the record books, but we've had some exciting time over those 20 years, and I'm still flying, still loving it. But yesterday when I flew across the country, it was all GPS, and it's so easy nowadays. And I know what Dick's talking about, because I've been flying for 40 years back when ANNs were still being phased out. So
that's something right there.
So Blake, are you ready for your 5 minutes?
Well, I wish I were qualified to be on board that XB1 the first time, but I barely remember the pre-GPS era, because I got my private ticket in a 172P model, and so I remember cross-referencing VORs, but that does feel like forever ago. But what drives me is being able to inspire other people around me to go do these things, and to convince everybody from engineers to pilots to investors that they can do more than they think they can do, and then go off and do something really important.
So Blake, is there any one aviation legend that you can think of that really, I know you're a dreamer, you're an inventor, you have all this, to do what Bert and Dick have done, which is create something from nothing. Who are your biggest influences?
Well, there's so many we could talk the whole time about it, but I'm going to mention Dick's brother here, because he gave a TED talk in I think it was 2003 or 2004. And I imagine a lot of people on this line have seen it. If you've not, quit listening to me talk and go watch that. Because he talked about what they were doing out in the Mojave Desert with the Spaceship One and Spaceship Two, and how the power of a small group of motivated people without the encumbrance of a kind of a big government program can go off and do things that other people couldn't do. And I remember watching that, and it inspired me a lot. And I showed it to all my friends, and I'm like, he got that thing in there about how we never move forward from Concord, and like, why isn't anybody doing that? And it stuck in my head, and I kept waiting for somebody else to do it, and figured maybe I got to go find the people to do it.
Excellent. Dick, we have a question in our chat for you. Can you speak to the relationship between Scale Composite and Tacit Blue? Somebody's asking.
Yeah, specifically talking through about what?
About Scale Composite and the relationship with Tacit Blue.
Oh, Tacit Blue and Scale Composites.
Mm-hmm.
I'm not sure that they were the same program. Tacit Blue was a military classified program for stealth, if we're talking about the same thing.
Yeah.
And Scale Composites, a large part of what Scale does is behind closed doors. And maybe someday they'll find out what that was. That's pretty amazing. But the stuff that they've done outside of that, you all know about Spaceship One and Spaceship Two and the Voyager, and the world's longest flight in a rocket-powered aircraft. Yeah, it's really interesting. I claim to hold two of the records: the longest flight ever flown and the shortest flight ever flown. And I'm really proud of the short one with the rocket-powered airplane, because it's 8.4 nautical miles. It's a national aviation distance record, and it's a record that's impossible for anybody to break. because you can't fly a shorter long distance flight. It's not possible. Anyway, so we had a lot of fun with that.
Excellent.
We at the National Aeronautic Association will look forward to somebody hearing what you just said, Dick, and seeing if they can come back and try to send us a record for us to certify. I'll let you know if somebody tries it.
Amanda's going, I wonder.
Yeah,
No, that's
the
a
shortest
tough
long
one.
distance flight in history.
Shortest, fastest, long. That's a tough one. And
Yeah.
say, Amen, you should point out that Tacit Blue, the actual aircraft, is down the hall from you at the Air Force Museum. It's on display nowadays. So
That's
I
right.
think I'm horrible at aircraft. That's a little secret because I focus on the people, and it's like whenever you mentioned the XB1 or the XB70 the other day, I'm like, I know what that is because there's only one. I know what that is, and that is down the hall from me.
yeah, and there's only one Tacit Blue, and it's about 50 feet in front of the XB70. So
I knew that.
Go down and take a look at it.
Let's go ahead and throw up the Greg, I'm sorry. Are you ready for the first poll question?
Yeah, I was going to say exactly the same thing. Let's do the first poll question. And so has aviation evolved enough since 1958 and the widespread implementation of jet engines, especially in the commercial side? And and I'm going to have Blake answer this last because I know you've got some thoughts, but the inspiration for this question comes from my old friend and Hall of Fame enshrinee and NAA Wright Trophy winner, Herb Kelleher, who always told me that there's been nothing new in aviation since 1958. It's all on the margins. And he was talking about, new airframes and engines and all that. To him, it was just all sort of all on the margins. I think we probably have some different views on that here. So we'll see what the audience says, and then maybe in order, Amanda, Dick, and then Blake can take that on.
Sure. Yeah, I mean, I answered no because it has been the margins, and the aircraft that we're building today, they're matter of fact, they're not going faster; they're going slower. When I worked back at Douglas and we were working on the C-17, the Air Force doesn't even operate that at the speed it was designed for. Why? Because it's not fuel efficient to do so. So they pull it back in speed. It's, we're certainly more efficient. We're quieter. We go longer ranges. We carry more people. And one could say thus we're more effective. But technology wise, at least, we've been doing those evolutions. It's time for a revolution. I'll talk about that a little bit later.
And it seems like our audience agrees with you. 57% to 43 say no. Dick, your thoughts?
Oh, well, and it's, I'm really glad that came up there, and I'm really glad that Blake is here. And I've been saying this for a long time, is that commercial aviation has been stuck at 0.8. I mean, for how long have you been stuck at 0.8? Got 60 years or more. But anyway, I was wondering, I go into an executive jet. Boy, they're really plush. They got the best entertainment systems and the golden potties and all the fancy stuff. And then I finally figured out why that is. And it's trying to mask the fact that after all these years, all these people back there, they're still stuck at 0.8 Mach, for crying out loud. And it's about time that somebody did something about that. And if I may, just for a minute, back 100 years ago when the automobile first came on the scene. Now, there were some rules when the automobile came out, the gasoline engine and stuff. You had 2 weeks in advance, you had to make a request to the city council about the time and the date and the route that you were going to drive this vehicle on the road. And they had other requirements. It says you have to be preceded by somebody walking with a red flag to warn people. Okay, those were the rules then. Now, obviously the rules are going to change, and we don't have people walking with red flags on automobiles because we evolved. And they talk about why you're stuck at 0.8, for crying out loud. And somebody comes back and says, well, the rules say that you can't fly supersonic. Well, I say BS. Just like in the days they did away with the red flag for automobiles, they're going to do away with that when we finally get off our tail and really make efficient airplanes to fly faster and more efficiently. And anyway,
And
that's my feeling about that.
I want to hear Blake's feeling on this. I know you've got some pretty strong thoughts. I want to play a little devil's advocate there. I mean, a lot of the technologies that you're using are new, right? New materials and efficient engines and those. I mean, there are things that are new. So, is it really fair to say that there's nothing new since 1958? What are you going to do about it?
Well, I think the key word in the question was enough. And we've changed everything about aircraft except the thing that matters to passengers, which is how well they do their job of getting them from point A to point B. And and we are, I think many of us on this call are too young. I'm certainly too young to have lived through the transition from props to jets that we had in the 1950s. And it's not taught in schools. And I don't know, maybe someone on this call will correct me, but I've never found a good book about that history either. I had to piece it together myself. But because it wasn't about flight attendants and the jet set. It was about the world becoming way more accessible. And there are these amazing anecdotes, like Hawaii before jets, tens of thousands of people per year would go, and now it's tens of millions. Like an island vacation is possible in the world because of the jet. We can have fresh flowers year round because of the speed of the jet. We can even the shoes we wear, like Nike. Nike got its start when the founder Phil Knight went to Japan on a lark after business school in the 1960s. And he fell in love with Japanese running shoes, and he started flying back with them and importing Japanese running shoes to America. And that's why we have the sneakers that we have today. And these stories go on, and I suspect there are a bunch more of them that aren't told. And so we have, what have we done since then? Well, we've made the machine a lot more efficient, right? And because of that, more people can fly than could fly in the 1960s, and that's important. But we haven't made the human more efficient. And the human more efficient is about, what's the barrier between where you are and where you'd like to be? And, with what comfort and ease and convenience and speed can you get from where you're going to where you'd like to be? And we've actually gotten worse on that. Not only have the Mach numbers eroded a little bit, but, we've put all kinds of barriers up in airports. We've made the flying experience really stressful and not special anymore. And I think it's time to go. I think it's time to go back to the future here, and have an air travel system that us aviation geeks can nerd out about the amazing technology that makes it possible, and the carbon fiber and the fly-by-wire and all the amazing stuff that makes the machine possible. But what we want to have for the passenger is they don't even have to think about it. They just decide to go somewhere and they're there. And it's a minimum of time, minimum of cost, minimum of hassle. And that's the world where we can start to get some more of these second order effects. When we have supersonic, there's going to be another story like Nike. There's going to be another story like flowers. But I don't think, I'm certainly not smart enough to anticipate what those are going to be and what's going to happen when the planet's more accessible to our innovators and leaders. And so we got to go make that happen.
That's the perfect lead in, Amy, to the next question that we have. We'll put up there. When will we be able to buy a ticket on a supersonic aircraft? And while the audience answers, I want to sort of again play devil's advocate and have a little fun with this, and ask Blake and then Amanda and Dick to respond. What the airlines always say, for example, is all people care about is frequency and price. They don't care about anything else. That's all they care about. When I worked in the airport sector for years, that's all we would hear. And they don't care about even how big the seat is or any of that kind of thing. I know you're working with Japan Airlines, Blake, which I think is a really interesting. I've told you this privately. One of the more conservative airlines in the world, working on a revolutionary technology like this, I think is a really cool thing. We'll see what the audience answers are, and then I guess the question is, is there demand for this, or do people really want it? And it seems like people. So 76% of the people who answered think it'll be certainly in the next 12 years. A very optimistic group, I think, which is great. I mean, aviation is not possible with that optimism, right? So Blake, what's the answer?
Well, I think the sarcastic question is, when can you buy a ticket, but when can you actually go cash it in and ride on it? We're going to have passengers by the end of the decade. And if we can pull that to the left and make it happen faster, we're going to do everything humanly possible to make that happen, short of skipping any steps and cutting any corners. So these things take, when I talk to my friends outside of aviation, they say, why in the world does this take so long? Can't you just do it in a year or two? You just get off your duff. And they don't understand the complexity of what goes into a modern safety critical machine and how much that, I guess it's the other thing that actually has progressed since 1950s. We made a huge progress on safety. Some of that's come at the expense of our ability to move and iterate quicker. But all the technology is out there. It's a design and engineering problem. It's a capital formation problem. It's an execution problem. It's not a science problem. So, for that reason, we can do it as fast as we can. We don't have to invent anything. We just need to go put the bits together that we already have. And, and for that reason, yeah, we're going to have passengers by the end of the decade. And, I think by the end of the next decade, we're going to have supersonic tickets that cost the same as what we're paying in subsonic today.
Wow.
Amanda, any thoughts on that? We're going to get into, this is really about time and distance and so forth, right? And we're going to get into some issues about propulsion and environment and sustainability in just a minute. But you work for a company that sells airplanes to airlines. Are you hearing from your customers anything about this? And
well, I mean, you said a key word, Greg. You said all. That all anyone wants to hear about is frequency and cost. And we certainly don't think that's true. There are people at one end of the market that are all, that don't care about price. They want to get there now, and they're willing to pay, what, they think is a reasonable price to get there faster. And whether, it's going to be, Blake and Boom with their airliner, or, Elon with SpaceX launching rockets from one spot on the earth to another very, very quickly with passengers. I don't know where it's going to be. There's certainly some options out there. Our focus, and we'll get to that in a little bit, is the other end of the customers, which are, we're happy with going 0.8, but we want to do it cleaner. We're very concerned about the environment, and we want to be quiet, and we don't want to be polluting, and we don't want to be changing our environment. So you can't say all, because it's a very, very broad spectrum, and that includes lots and lots of different people.
Right. Good questions coming in about some of those things which we want to transition to in a minute. But Dick,
I'd like to chime in on this a little bit. And and I say that I must be critical of the airline companies. They offer an inexpensive price and a reasonable chance that you are going to get there on time. But if you take a step back and look what the airline companies have done, I'm not talking about the manufacturers, because I've also talked to the Airbus's competitor here in the States, which I won't say, but their initials are, I think, Boeing. Is it?
We just refer to them as the B team, but that's okay.
Now the B team.
I'm going to be getting a call or an email.
Both of you do an outstanding job. But if you step back a minute and look at this system for the passenger, we have an electric car that's almost automated drive, can drive down the freeway at 80 miles an hour. Now, to transition from that mode of transportation to an airplane that'll go 0.8 at a reasonable cost, the people that do that, they ought to be ashamed of themselves. It's the most inefficient, horrible, cattle-driven operation that you can. A passenger, back in the old days, they used to treat you nice, but nowadays, how the airlines get you out of your car and into that airliner seat, they ought to be ashamed of themselves. Where you can park, the hassle, the lineup, just how they board an airplane. It's maddening. And I asked the airline company, and I said, "Hey, why don't you put more doors on it so you can efficiently load and unload an airplane?" And they'll turn around and says, "Well, this is what United wants." I said, "The hell with United. If you guys want to sell more airplanes, for crying out loud, well, get involved in the efficiency of getting people out of their cars and into that airplane going 0.8. If you could do that, you would revolutionize the whole system. But right now, it's just a pain in the neck to go in the airlines. especially at the major airline terminals.
It is. Yeah, I'd love to riff on that a little bit. I think one of the big challenges, and I don't know the answer to this, is that we today the air travel system is a trifecta of the airplane manufacturers, the airlines that operate them, and then the airports, and they're different entities. They don't have common motivation, and some of the most interesting innovations require that you be able to touch all three of those points, to what Dick is saying. And so, I'm sure the people on this call, if they brainstorm for even 5 minutes, we'd have some great ways that you can make that experience 1,000 times better than it is today. But it's going to require you touch all 3 points, and that's very hard to execute. And we got to figure out how to solve that problem to really make progress on this.
Yeah, I think, to make fun of it, I was flying myself, as I mentioned yesterday, and I'm flying at 0.2, right? And it doesn't take me all that much longer from one point to another, on the order of 1,000 miles or so, than it would be on an airliner, quite frankly, because I don't have to deal with all the things that Dick just talked about. So it's not sometimes about speed. It's about that convenience, and it's about the experience, the overall experience.
Well, and I think that's one of the things that we found in, I think it was our first webinar, and Dale Clapmeyer was on that webinar. It was a really good one. They're all on the Hall of Fame and NAA website if anybody wants to go back. But one of the things we're finding in COVID is that people who are nervous about going to the airport right now are finding their way on general aviation aircraft and business aircraft. So Bombardier, Gulfstream, Cirrus, those businesses are taking off. They've only grown during COVID, and it's because people are feeling, and I'm not saying it's good. I want commercial airline to, I want commercial travel to be successful, but people are exploring those other ways of traveling where they might, because of COVID, feel health safety wise, but now it's becoming a convenience thing. So that's why I'm excited as we get more into this. We're going to talk about, things like vertical takeoff and that kind of thing. But should we go ahead and go into our third poll question, Greg? Are you ready?
Let's do the third poll question. While we do that, there's 2 questions from the audience that I think also tee it up. So while the audience is answering this, we have a question from Robert Oleslagers. It's not just about the propulsion system to go faster, but what about environmental impacts, for example, noise and emissions and so forth? And Scott Newman asks, aircraft innovations seem to follow new propulsion technologies. What do you see in terms of scramjet, electric flight, single stage to orbit, and so forth? So a couple of good audience questions that tee up this question here.
And Greg, Amanda's going to talk about Ed Warnock's question about zero emission flights. So
Perfect.
We'll do that as well.
So while we get the answers from the audience, Amanda, you want to get us started on this?
Sure. So let's see, how do I want to actually introduce this? So, at Airbus, our predecessors were the ones that built the Concorde, right? The companies that built the Concorde ended up, working together and then forming Airbus. And our focus has been in the 50 plus years of, since Airbus was founded, was being more efficient and bringing the cost and the complexity of air travel down for our customers and for their customers, the traveling public. And that's what we've been focusing on. And there's been a more and more, with our newest aircraft, either our 320 Neo line, our 330 Neo line, and of course our new 220s, they are, 15 to 20% more efficient than the aircraft they replace. So we're trying to be, cleaner, we're trying to be greener, and we're now starting to look at what the next option is. So if you can roll that video in the background behind me while I talk, I'm going to talk a little bit about what we're proposing now, which is to go to hydrogen combustion on aircraft. And we've introduced 3 concept aircraft. No, that's the wrong video. That's the, yeah. If we can get the other one. Blake will talk about his rollout. last week, but we're going to talk about, we're looking at a 0.5 turboprop. There we go. Let's go back to the beginning. I'll talk a little bit about each of these aircraft. So they are zero emission. They burn hydrogen, so no exhaust other than water vapor. So one is to take a single aisle aircraft, redesigned. It's going to operate at 0.78. It uses turbofan engines, going to go about 2,000 miles, hold about 200 people. We're looking at a possible turboprop. It's a 0.5 aircraft, carries 100 people, goes 1,000 miles with no emissions. And this is our kind of advanced concept. It's a blended wing body. Again, would carry about 200 people, go 2,000 miles with no emissions, just water. So, we think that it's going to take us about 5 years to work on the technology so that they're ready to actually move to the next phase. So, what does it take to handle that type of fuel? Because this, hydrogen, liquid hydrogen replacing kerosene is the major component on the aircraft. So that about 5 years from now, we would start down the how do we industrialize it and design the aircraft with a designated entry into service in the 2030s. We've already have a few airlines that have expressed interest, no deposits yet, mind you, because we're still very much exploring this. But people, I think, are very excited about the idea of having no emissions on an aircraft that can truly fly long distances and carry people like they do today.
Talk a little bit too about the design and infrastructure challenges that you have with that. I mean, the fuel has to be carried differently, and
oh, sure. I mean, we've been working since 1958 on how to deal with kerosene, and built an entire structure around the refining of that, the transportation, storage at aircraft, uploading into aircraft, and then of course how you store it on board the airplane. So we've been working on that for a long time. It was considered extremely dangerous when kerosene first was introduced into aircraft, but for almost 60 plus years, we've refined that, and we've gotten very, very good at it. So all those same infrastructure challenges will be there for liquid hydrogen. Certainly, it's temperature controlled. It's very, very cold for hydrogen to be liquid. But it can be created almost anywhere. You don't need big petroleum refineries. It can be generated from wind and solar power. All you need is air and water. And so there's some really opportunities there. But then how you store it, how you transport it to the airplane, how do you put it on board the aircraft? All those are things that are going to be looked at over the next 5 years. We are quite optimistic that those challenges can be solved on a long term. I mean, we already see hydrogen on ground transportation, whether it be local buses in our metropolitan areas. We're seeing more hydrogen powered cars and trucks for industrial fleets. So hydrogen is on its way to becoming a very widely accepted fuel source. We're just working now hard to put it into aviation. And we're not the first. An airliner was flown on liquid hydrogen decades ago. And we have some startups that are flying aircraft today powered by hydrogen. We're just looking to say, how do you do that for an airliner? And we're very confident that that will be the future of aviation. Clean and environmentally friendly.
Probably have to go in that direction, right? Permission to grow, as they call it in Europe. Go more in that direction. Amy, do we have the, there we go. So pretty much, 51% say 2035, and the other half say we'll have it by 2032 in one way or another. Hydrogen, electric, or other such propulsion systems in wide use. What do you all think of that answer, Dick?
Oh, that's very optimistic. Everybody wants to be to run clean and efficient. And but there's some big obstacles to overcome. Another thing is that that's already at work, and even out here in Mojave and in other places out here in California, some of my colleagues, they've been working on the hydrogen airplanes and mainly electric propulsion and so forth. And the ability that all those flying machines going to be operated now with fly-by-wire, so the pilot doesn't have to actually manually do all those things. And I'm just wondering when all of that fly-by-wire stuff is going to be evolved into general aviation. And for Lord knows that general aviation is so sorely in need of another propulsion unit. It's an absolutely golden opportunity for somebody to come along and make that computerized and much more efficient. But another thing is that general aviation needs to be bloody quiet, for crying out loud. This attitude is, well, if you don't like airplane noise, don't live next to an airport. If the automobile industry had the same arrogant attitude as that we have now in general aviation, there would be no automobiles. But and there's a couple of programs right now we're going to solve all those things too. About we can run quiet, we can run super efficient, and also very clean. So I'm pretty excited about general aviation with a decent propulsion system, and that's long overdue.
We're definitely on the cusp of the next big thing in aviation. Blake, why don't you tell us what it's like to try to get support for your dream?
Yeah, well, it's what I've found is the more inspiring the mission that you pick, the better your ability to attract great people all around you. And when I was starting Boom 6 years ago, and I would tell people, "Hey, I'm going to build a supersonic jet," the first question that you could tell they had, you could just read it on their face, is, "Are you crazy?" And if you could convince them that the answer was anywhere close to no, if you had even just like 10% no, then the next question was, "How can I help?" And some of our earliest investors would say things like, "I think you have like no chance of success, but I really, really, really want it to work, so here's some money." And then as we went on, we could get better and better people. And the folks who would call me up when they thought I was making a mistake because they so wanted this to succeed that they tried setting me right, are just phenomenal. And so the lesson I've learned along the way is if you're ambitious and you're driven, like, you're always going to work hard. And no matter what you do, you're going to be pushing yourself to your limit. And it feels the same regardless of what you're doing to be at that personal red line, because you're working as hard as you can. But what's different is the motivation for yourself and for the people around you. And so if you're gonna work as hard as you can, you should pick the biggest, most important idea you can and work on that, because then it's worth it. And then that becomes contagious. And all of a sudden people around you start saying, well, can't we do more? Can't we think even bigger? And I think for me that bridges back to the conversation we we're just having about next phase propulsion systems. And I think a lot in the back of my head, and some people here at Boom, about, well, what's the best way to get energy onto the airplane? And you care about volumetric density, you care about mass density, and you care about net emissions. And if those are your guiding principles, it takes you in some interesting directions as you follow that brainstorm, and you're willing to think. That's the other thing. You have to be willing to think, more than just 5 years out. And if you're able to do that, you're able to let go of a lot of traditional assumptions and constraints, and you can start to find your way to some big breakthroughs.
Well, that makes me think of when I visited Boom, and I was looking at the outside of the aircraft, and I could see it was composite. And I remember one of the people giving me the tour was like, "How did you know that was composite?" And I was like, "I know things." And so the technology is so exciting, that to see that, and then to fly like the 787 or the Dreamliner or something like that, and know that that's using that technology. And it makes me think of a conversation I had with Dick whenever he was talking about the importance of weight on Voyager, and how he and Bert were fighting over the skin of Voyager. Dick, can you talk about the technology that went into Voyager and that kind of thing?
Well, we talk about propulsion, and I was asked to give a talk to a group of engineers for the major propulsion company that was back east. I won't say their name. Anyway, they're going to introduce some of their engineers into the fellowship. And I thought, what can I really challenge these people with? Because if people don't get challenged, they don't really try to do that. So what I said is that I'm going to try to remind them of that the fourth state of propulsion. The first state of propulsion, real quick, is the human with an animal and walking human power across the ground. And the second stage of propulsion is they use heat energy to make steam engines and so forth. And they have gasoline and gasoline engines and diesel cycle engines. And then they use that to propel themselves. And then the third state of propulsion is, the fourth state of propulsion is called action and reaction. And if you think about to start all this, you have to take particles, matter, and you have to accelerate it one way so you can go the other way. So it's action and reaction. And the problem is that eventually you're going to run out of particles to accelerate. Now, if you can heat those particles up and accelerate them faster, they can be more and more efficient. And I challenge them. I says, the next stage of propulsion, the challenge is that you can propel yourself without the expenditure of matter. And they all looked around at me and thought I was really crazy. But then I reminded them about something too. Is if you go back 100 years or more, 150 years, in the high plains of Kansas, and there's a Calistoga wagon being pulled by an oxen. And he's going from St. Louis to a new life out in Oregon territories. And you come down beside him and you try to tell him about a propulsion system that you can fly next to the speed of sound, high in the stratosphere, pressurized comfort, eating lobster thermidor and watching Cinerama. Well, they used to do that. They don't do it anymore. But describe a propulsion system to them. He couldn't even imagine it. And when I tell you that your challenge is to make a propulsion system that you can accelerate without the expenditure of matter, then they would think the same thing. He would think the same thing. The covered wagon guys say the same thing about what you're talking about in the future is what I'm trying to talk to you right now. So you got to dream a little bit about that. There's another way to do that. It may be simpler than what you think.
You know, Dick, I'm going to leverage that because I've read about and saw some of the researchers up at a university out east where they actually flew an airplane that had no moving parts and did not use any material on board. It used electricity to charge air particles in front of it and then an anode in the back to attract those particles over the wing. And so it did not expel any material. It actually pulled the air towards it over the wing to accelerate it and create lift. Didn't fly very far. It was very, very fragile. It was inside a gymnasium, but it was indeed no moving parts and not expending any material. Who knows? Maybe that is going to be the next great thing.
Well, that's exactly the vision and thinking about how that's going to be done. But I think also, if that is ever achieved, it's not going to be achieved by a big aerospace company. It's going to be achieved by some little old grandpa that figured it out in his garage. That'll change the world.
That's kind of what Blake did.
There's been
Grandpa, huh?
Dick, do you have anything in the works that you aren't telling us?
You're right. Is there news you can make here?
Yeah, can we do the next one of these from your garage?
I have an old adage: if you can dream it, you can do it. And the only way to fail is if you quit.
Right.
Now, I've often heard it said that Julius Caesar and George Washington got around pretty much with the same technology, right? We didn't progress at all over all those years, and look what we've just done, in our lifetimes. It's an incredible thing. Amy, given what the time is and all that, I had some other questions about the investors and capital markets and stuff. We might have a book to give away.
We do. And I also want to give Blake the chance to tell us a little bit about what he's doing.
We put up the next question, it looks like. Oh, no,
Yeah.
it went away. Never mind.
Okay.
Okay.
So we want to give away a personalized autographed copy of Dick's book. And what we want to do, because we're all about inspiring the future. And I almost want to joke and say Blake's not allowed to do this, but we want to give it away to the youngest person on this webinar. So if you think there's a chance you could be the youngest person, go ahead and put your age in the chat, and we're gonna have Dick personalize this to you, and we'll send it out to you. And we will allow Blake to join in this, because it's pretty awesome. The next 5 minutes available on dickrutan.com. But if you don't mind, Greg, I'm gonna throw it to Blake, because I think it would only be fair to give him a moment to talk about what he's doing out there at Centennial.
Absolutely.
Yeah, thanks, Amy. Well, I think I expect a lot of people on the call are familiar with what we're up to. The long range mission is to make the planet dramatically more accessible, and we've been talking about the job airplanes do, and it comes down to being able to travel faster, cheaper, and more conveniently. Because if you can accomplish that trifecta, those are the reasons, COVID aside, that people stay home and they don't go, and opportunities are lost. And so one of the things I learned from the early part of my career working at Amazon, and I got to work a little bit with Jeff Bezos, is if you want to build something that's going to create value for a long time into the future, and you want to be able to make long range bets, what you do is you focus on things that are going to stay the same, not on the latest trend. And it's hard to imagine a future in which people want flights that are longer, that cost more, or they want more of that, TSA complimentary massage. So if you can build an organization that's focused on those fundamentals, you can start to think very long range. You can make some long range investments, and you can be confident that you're creating value long into the future. So that's our long-term aspiration. And what we're trying to do now is just get the flywheel started. And that's what we're doing with XB1, which is the technology demonstrator for Overture. And Overture is the first, it's gonna be the first mass market supersonic airliner. It's gonna be available to tens of millions of people per year at fares similar to what we're paying in business class today. So that's not everybody yet, but it's if I can make the analogy to Tesla, since Dick kind of gave me the lead in on that earlier, XB1 is our Tesla Roadster. And Overture is our Model S. It's a lot more affordable to a lot more people, but it's not yet for everybody. And then as we take everything we learn from that, we're going to build Overture 2, or maybe we'll call it Encore. That'll be progressively, faster, more efficient, more affordable, more convenient, until we can get to a point where the fastest flight's the cheapest one. And I deeply believe we can do that. There's nothing physically impossible about it. And one of the reasons it works is, as you go faster, your fundamental challenge is fuel efficiency. Is what's the cost to propel the aircraft forward in terms of fuel? But if you make enough progress on that, what you find is all the other factors are cheaper the faster you go. The rent on the airplane, how much pilot and crew you need, even catering, because you can't drink as much wine on a short flight as you can on a long one, right? And we call that the speed dividend. And if you look, and that we've been through this in the past, right? When we went from props to jets, the first jet aircraft were not as efficient as the propeller aircraft we had, but they were faster. And then as we started to iterate on it, they got to a point where they were cost competitive and then better versus prop aircraft over long distances. And we're gonna see the same thing with supersonic. We just got to get that flywheel spinning. And so that's XB1, the prototype aircraft that leads to Overture, and then maybe we'll do an XB2 and an Overture 2 along the way, and not quit until maybe 100 years from now. Hopefully our descendants are working on the 100 millisecond transporter beam, because it's a big improvement over the 300 millisecond transporter beam. And if you stop and think about it, it actually is way better to 100 milliseconds. But there's a long way to go before we've got diminishing returns.
So Amanda, when Blake does all that, will Airbus and that other B company, Boeing, want to jump in too? You wouldn't want to stand still and see another company take all that.
Well, like I said, we've done supersonic. We actually were investing in supersonic aircraft. We had a partnership that ended 3 years ago. So we've been kind of looking at that. We think right now that supersonic is going to be a niche if it comes about. But for the general public, they're very, very satisfied with their overall experience, as Dick says, at 0.8, and that the overall improvement or reduction in total travel time when you're going 1.4 is not going to be all that significant. But time will tell, and we'll see what the future is going to be. I don't think that they're, we don't build turboprops right now, right? We own a share of a company that builds those. We don't build regional aircraft other than the 220, which is just starting to get down into that market. We don't build general aviation. We don't build business jets. There's a lot of different parts of the market. And we think that we've got our section, very well in hand, and we're going to push it forward with a cleaner and quieter aircraft.
Yeah, well, Amanda, I agree. 1.4 at 1.4, the juice isn't worth the squeeze, so to speak. You got to go faster than that to turn an overnight flight into a daytime flight. That's where it gets interesting. But I think this goes to the role of different players in the market. And if I put myself in, I'll say brand B shoes, I got to go after the biggest market with the least risk, and I can't do something that undermines the Dreamliner. And so there's sort of a role for that, and like sometimes the technology changes radically, but the customer experience doesn't change as much, and then that leaves a space for new entrants to do the opposite thing, and I think that's very healthy for the world.
I just want to go to London for lunch. I'm not going to lie. I just want to go have lunch in London and come home again. Who doesn't want to do that?
Yeah, so, unlike Dick, who I'm quite sure has flown supersonic, I have not, but I do. But my dad tells me of having breakfast in London and breakfast in New York on the same day, because flew the Concorde.
Right on. So I'd like to congratulate Rishikesh, who's an 18-year-old joining us today. He's going to get a signed copy of Dick's book. Lots of younger people are on this webinar, including Robert Olasagers, who claims he's 5 years old, but we all know that that's a lie. We love you, Robert. But yeah, so thanks Joshua, who's 39, and Riley, who's 21, and but Rishikesh is 18, so that's just fantastic. I'd like to close with poll question number 5, and as people answer, I want Dick Rutan to tell us what predictions you have for the future of aerospace.
Yeah, as you all see, the commercial supersonic flight, non-fossil fuel propulsion, vertical takeoff airplanes, we have and passenger travel around the globe through low space. That's sort of inspired by that space plane that was being developed in the late 80s, where you can go through low and get to Tokyo in 2 hours from New York and that kind of thing. So,
well, the two major airline companies that provide flying machines, I want to beg you again to get involved in what the airlines, what the airplane or what the companies do when they get these fantastic, reliable, safe airplanes, how they utilize them. And I'm still really upset about what I have to go through to get out of my car and get into your fantastic airplane. I need the airlines need to get involved in that and fix that, because what I'm saying is that you're going to be able to sell a heck of a lot more airplanes if you fix that bottleneck and the passengers not treated like cattle in a cattle yard.
What do you say, Amanda? What's the future of aerospace? And Amy, let's go ahead and get the results. Sorry.
I think, and it's very interesting and glad that what we see the results are that people are supporting the non-fossil fuel propulsion. But I think there's going to come a time, and we're seeing it more and more, and it goes to what Dick talks about, is when we have these advanced aircraft services where they're going to pick you up in front of your house and they're going to transport you either to a larger hub or be able to take you, transition into a fast flight and take you wherever you need to go, and it'll bring you right back down. And so that the overall experience is going to be quicker and more pleasurable. Now, there's a lot that has to go into all that. And the economics are certainly a huge, huge portion. But it's something similar to that, more of a hub and spoke, where the spokes are starting to get longer, and lots of shorter ones that are more individually monitored. It's going to be an interesting future we're going to see.
Blake, what say you?
This might be sacrilege in this group, but I don't think it's about technology. I think it's about what amazing benefit we can provide for the public. And so there's a lot of technology that goes into that, but it's about furthering, what we created aviation for, a better way to get around the planet. And the how is going to change over time, but we can't lose sight of the what.
So well, Amy and Greg know that and I'm going to promote it. And I think, from some of the comments, I think Blake has seen it. There's a movie that I just really, really enjoy. It's called Living in the Age of Airplanes. And it talks about the impact of aviation on our society. And it's phenomenal just to think about how we have changed since aviation in the 114 years since we started this industry up. How it has impacted our global society. A little bit of a pause right now, but just think about still all the amount of cargo and information that is moving through the skies at any moment. It's phenomenal.
Well, the Hall of Fame is working on our documentary, and what you just said plays a big part of that. And it's all because of the people, whether it's in trainees like Dickerton or in trainees yet to come like Blake Scholl. I mean, it's exciting to see what's going to happen over the next 50, 100, 114 years from now. Thank you all very much for taking part and being with us today. I'm not sure what just happened, but hopefully everyone can hear me. Thank you, Dick. Thank you, Amanda. And thank you, Blake. And as always, thank you, Greg, for joining me on this journey. Have a great day, everyone.
Thanks to all of you. Thank you.
Thanks for having me.
Bye-bye. Thank you, everyone.
Bye-bye. Thank you all.
Dick, you have to say bye.
Well, thank you very much. And invite me back again.
Absolutely.
We'll do.
Anytime.
Thanks. Bye, Dick.
Everybody.
Bye.